Hey, I'm Ryan.
I'm Ryan.
I'm Sean.
And I'm Wesley.
And we're computer scientists making a pinball machine for E101 section 13. We're just going to go over our design process for our pinball machine that we made.
So step number 1 of our design process was to identify the problem. And the problem put before us was to develop an arcade game for Freshman Engineering Design Day. Step number 2 of our design process was to identify criteria and constraints. And so following our rubric, we knew that we had a $40 budget and we had to have 4 power sources, including 1 using player skill and 1 using passive action, and the dimensions had to be 3 by 3 by 2 feet, and we also had to use easy to find materials like wood and a mechanism to calculate the game score. And our arcade game also had to be portable and safe with no projectiles.
For step 3, we started to develop ideas and brainstorm about our arcade machine. We had to use a lot of easy to find materials as per the constraints of the rubric. So we decided to go with wood, and we decided that we were going to make a pinball skee-ball machine mix. Now, this led to a lot of complications that will be discussed in step 4.
So step 4 was generating ideas, and in order to do this we all met together at DH Hill and just threw out some ideas and drew some sketches to try to kind of figure out exactly how we were going to design this pinball / skee-ball machine. And part of what we had to do was design the flippers and the launcher, which is also known as the plunger. And these things were very important because it was one of our major actions, which was to have the player controlling the ball.
For step 5, which was explore some possibilities, we went more into depth with the type of plunger or flippers that we were going to use. For the flippers, we were originally thinking of using some hose tops in order to twist them in order to make it so that you would have better control of the flippers, but we found out that it seemed kind of difficult and awkward to use, so we went with the elastic flippers on the back, which I'll show later. And for the plunger, there wasn't much to go into that. We weren't exactly sure how we were going to build it. We knew that we could definitely use springs because that had to be one of our sources of power, but we weren't exactly positive on what materials we were going to use. It ended up we used toilet paper roll and some connects, but in the beginning we were thinking of using some more easy to come by materials, but yet again, childhood memories right there. We were thinking of also for the scoring mechanism, we had already known that we were going to do the holes in the game board, but we were thinking, since we were all computer scientists, that we had to throw in some electronics, but with our tight budget constraints, it just wasn't possible. So we ended up having some slots underneath to catch the balls when they fell through the board, and we had the scores written on the game board itself. For step 6, we had to select an approach. For that, we'll have to get a little bit closer for this. The plunger, we had already mentioned that we use connects, but the insides of it aren't that complicated, but I feel like it would be best to go over it. Right here is how it works, and then there's another piece that attaches right at the end. The inside is right here, the individual connect pieces. Had this in order to catch the plunger at a decent length, or else it would be jiggly and stuff like that. This is just your average toilet paper roll. This right here looks different for connect pieces because usually there's more brackets on the end, but that came into a problem with rubbing against the game board itself. This right here is the guides, which we had to include for the criteria right here, so that when it comes up that it guides right back down to the flippers. These right here make it a little bit easier to score for these lower point ones, and also it makes more visually appealing due to the fact that if there wasn't anything on the game board, it looked kind of bland, just having the holes and the point values. This right here we use for the elastic to wrap around. This is actually for screen doors, all to fit into that $40 budget. I'll show you the flippers underneath.
as you can see, we went with the elastic approach with the actual game board flippers rather than having those twisting versions. For this, we have the plunger pieces going through, and right here acts as a guide in order for this thing not to move around. These pins right here, since this is all upside down, if these weren't there, the plunger itself would fall through. Originally, it was a little bit too close, and it made a lot of resistance, so we had to put some washers right there. Right here is in order to make sure that when you push through, that this thing doesn't fall further back than needed, because if that was the case, then it would get in the way of the plunger piece, and this elastic band makes sure it falls back into place. This is connected to the flipper itself on the other side at about roughly a 90-degree angle. That way it just looks more like a pinball machine, due to the fact that it wouldn't look right if the flipper was all the way down here or up here. And in order to do that, we use a pencil for the dowel, and we have a screw going through right there, and we also use wood glue. And we did the same thing on this side. Actually, we used a nail. Right here is our scoring mechanism. So when the balls fall through, we use mousetrack balls, and they don't really bounce, especially since the fact that the game board only rests about 2 or 3 inches from the base board. So this way, when the ball falls through, it slides nicely to our laid out point values.
For step 7, we're each to build a prototype. We already knew what we were going to do for the flippers and plunger, but this is the entire incorporation of the final project. For the board itself, the entire encasing, we decided to make it, we had to make it so it was perfect in order that it was flat and level. If it wasn't like that, then the ball would lean to certain edges. In order to do that, it took a lot of measuring. We had to know the exact dimensions before we cut things, and we had to know the exact angle in order to make sure that it all worked out well. For when building the board, we decided to have the capability to slide it in and out, and it would be difficult to work with due to the fact that we wouldn't have access to underneath. You can see right here that the board itself actually does slide through right here. And that's just when we were designing it, that's how we did it in the beginning. So we had to put a piece right here in order to make it so that the ball would get caught, and also that was for a reason why we put a 0 point right here. That way, if the ball did roll through, it would land into the 0 point hole.
Step 8 of the design process is refining the design. In this step, we took our nearly finished product and we polished it up a little. This was when we painted it. We used a lot of painter's tape and spray paint and had to take everything apart and paint the individual parts just to make everything look nice, you know, kind of give it a theme. We ended up actually using nail polish to write the individual numbers for the scores because it was something that would last and stand out well. And this caused some problems, the paint did. For example, this was one of the buttons. As if you can probably tell, it's kind of not really painted. Originally it was painted, but this was causing too much friction to the point where the buttons would kind of like jam up or not work as fluidly when the game was being played, and so we had to shave off some of the paint in order to get it to function properly.
For step 9, the outcome of the presentation, we took our finished project, our arcade machine, over to the freshman engineering design day, and it worked really well. Everything went according to plan. The judges loved it. We got first place, 100 out of 100, and there really weren't many flaws at all. But if we were to do this again, there are just a couple things that we would do slightly differently. Like originally, we started spray painting this is just for aesthetics. We started spray painting the machine, and then right here, there's some that just kind of overlap because we didn't originally have painter's tape there. And secondly, well, a little bit more important, is when the ball rolls too fast, since it still has some bounce in it. When it hits here, it might bounce into a different score slot, so it doesn't 100% accurately go into the 0 every time. It's very minor though. Advice for future students based on that criteria is double check everything that you do. Make sure that everything works when you present something. Even if it is getting a perfect score at an engineering design day, it can still be better. I think that's the point of engineering, is that you can always improve on what you're doing.
Alright, this is for you, Sean. 400, calling it. Damn, that was kind of quick.
That was for me.
That was for you.
I've never